Hello everyone, myself I am Divya. I am from Department of Chemistry, working as Assistant Professor in Marri Laxman Reddy Institute of Technology and Management. So in today's session, we are going to discuss a new module that is from Engineering Chemistry, that is water and its treatment. It comes under your module 1 in the subject of Engineering Chemistry. So these are the topics we are going to discuss under first module, that is water and its treatment. That is first introduction and also the estimation of hardness of water by complexometric method. Introduction to the hardness of water. Okay, so water is essential for all living beings and water is very crucial. And the above, like earth is occupied by 80% of water, but in that only 1% of water is useful for us. Like 1% of world's water resource is available for ready use. And next we have to do a treatment for the water to use it. Next, as an engineering tool, water is mainly used for steam generation and also it is also used for the coolant, although different uses of water demand different specifications. So we have different demands for this water under different industrial uses. So some of the uses of this water under industrial uses is one is the textile industry, where we require a frequent dyeing of clothes, and the water is used by this industry should be soft and free from organic matter. The water which we use for the textile industry, it should be soft and it should be free from other impurities. And also for the paper industry, we require the water and it is free from SiO2, and also it produces as it is having this type of the compounds, it produces the cracks. So to prevent it, we have to avoid the chemicals. Next is pharmaceutical and dyeers. We need a ultra pure water. So in this case, now we are going to treat the water or treatment of water. So the impurities from the water are removed and the water is converted into pure water that we can use for these industries. So water treatment is a process by which all types of undesirable impurities are removed from the water. The process of removing the impurities from the water, we call it as water treatment. So first of all, what type of impurities it may contain? Water. So water may contain three types of impurities, mainly classified into three types, like one is physical impurities and the other one is biological impurities and the last one is chemical impurities. So this type of impurities are present in the water. Now we need to carefully remove all these impurities from the water so that the water can be useful for many other ways. So first one is physical impurities, that means color, turbidity and taste. So color, it is caused by the metallic substances, and turbidity is due to the colloidal and the fine suspensions such as the insoluble substances like clay, slate and microorganisms. Coming to the taste, taste is coming because of the dissolved minerals in water. It produces the taste. Coming to the chemical impurities, we have inorganic and organic chemicals. In inorganic chemicals, we come under the anions and the cations, such as these examples. And also the organic chemicals like paints, petroleum, pesticides, detergents, and also the drug textile materials and other organic materials. These comes under the impurities for the chemical impurities. Coming to the biological impurities means if it contains the algae like a bacteria and also the fungi, virus and the pathogens and parasite worms. If these are containing water, then the water will be impure. So if you see this any type of impurities, then the water will be contaminated, like chemical impurities, physical impurities or the biological impurities. Now we'll see a topic, that is what is the hardness of water. How hardness of water is caused. So hardness is simply, we can define it like a soap consuming capacity of water sample. That means our hardness of water means it can consume the soap capacity of the water sample. and it can prevent the lathering of soap. Hardness means it can prevent the lathering of soap. We have two types, hard water and soft water. Hard water means it can prevent the lathering of soap. Why it can prevent? Because of the certain salts. Because of presence of these salts in the water, it will cause the hardness. It will cause the hardness so that it can prevent the lathering of soap, or it can consume the soap. What are those salts? These are calcium and magnesium and other heavy metal ions like aluminium, iron and manganese. These are dissolved in water. These presence, like a presence of these salts, causes the hardness of water. If a sample is having a hard water, then when it is treated with soap, okay, you are having a hard water, and when it is mixed or treated with the soap, it does not produce any lather. It does not produce any lather, but it forms a PPT that is insoluble. You can see reaction below, like a hard water or a water sample that is having a calcium ions. Okay, these are the salts present in that water which is responsible for its hardness. Now it is combined with this soap, it gives to the curdy PPT, or it can mix with the magnesium, it gives the insoluble PPT. Understood? Okay, this is the hardness of water. How hardness of water is caused? Because of the presence of salts like calcium and magnesium and other heavy metals. Causes of hardness. So when natural water flows over the rocks containing chlorides, sulfides, nitrites of calcium and magnesium. In general, these rocks will be containing a calcium, magnesium, or the chlorides, sulfides and nitrates. Okay, these are responsible when these salts will dissolve in water. If you observe, when the water, natural water flow from the rocks, the salts present on the rocks will dissolve in this water, thus causing the hardness of water. These are some of the differences between hard water and soft water. As we know, hard water means it does not produce any lather, but the soft water, it easily produces the lather upon adding of soap. Next, it contains calcium and magnesium salts in it. This is why it is causing hardness, right? But it does not contain any calcium and magnesium ions. And the boiling of water is elevated, and more fuel and time are required for the cooking in case of hard water, but less fuel and time are required for cooking in soft water. Water is said to have hard when its hardness is 100 mg per liter. Okay. Next is, in soft water, it is below 100 mg per liter. Now we'll see types of hardness. Types of hardness, the hardness is classified into mainly two types, that is temporary hardness and permanent hardness. So first, coming to the temporary hardness, from the word we can see temporary, like we can remove it. Okay. So temporary hardness, it is caused by the presence of dissolved bicarbonates of calcium and magnesium and other heavy metals, and we also call this temporary hardness as carbonate hardness or alkaline. Why temporary hardness is causing? Because of the bicarbonates, dissolved bicarbonates of calcium and magnesium. Now this temporary hardness you can remove by simply boiling of water. By this method you can remove this temporary hardness. Now this bicarbonates decompose to yield insoluble carbonates or hydroxides, which gets deposited as scale at the bottom of the vessel. Now if you see example, calcium bicarbonate will give rise to the calcium carbonate and water and carbon dioxide. Same we can do it for the magnesium. This is the temporary hardness. Now we have other type of hardness, that is permanent hardness. So permanent hardness means, from the word, like we can understand that we cannot remove this type of hardness either by boiling also. Why permanent hardness is causing? It is due to the presence of dissolved chlorides and sulfides of calcium and magnesium. If you see presence of chlorides and sulfides in the magnesium or calcium, then you can simply say it as a permanent hardness. It cannot be destroyed by boiling. Permanent hardness, we also call it as non-carbonate or non-alkaline hardness. There we have said temporary is also known as carbonate or alkaline, right? But here permanent hardness is also known as non-carbonate or non-alkaline hardness. So simply total hardness we can derive by adding of temporary hardness and permanent hardness. You can see here total hardness is equal to the carbonate hardness, that is temporary hardness, and non-carbonate hardness, that is permanent hardness. So total hardness is equals to temporary plus permanent. Now we'll say expression of hardness, how we are going to express the hardness. Mainly in the units of ppm. Okay, ppm is nothing but parts per million as CaCO3. Okay, the choice of CaCO3 is due to the fact that its molecular weight is equal to the 100 and equivalent weight is equal to 50. And it is most insoluble salt in water. So simpler degree of hardness is equal to the weight of hardness causing salt we divide by the molecular weight of hardness causing salt. First we take the weight of salt and then molecular weight of the salt into 100, then we get a degree of hardness. And the other units we have for the expression of hardness apart from the ppm, that is milligram per liter, degree Clerk, and also the degree French. So parts per million means what? It is the number of parts of calcium carbonate equivalent hardness present in 1 million parts of water. That means 1 ppm is equal to the 1 part of calcium carbonate equivalent hardness in 106 parts of the water. Coming to the milligram per liter, it is the number of milligrams of calcium carbonate equivalent hardness present in 1 liter of water. Here everything reference we are taking as calcium carbonate. For the degree Clerk also, it is the number of parts of calcium carbonate equivalent present in 70,000 parts of water. And here also it is the number of part of calcium carbonate equivalent present in 105 parts of the water. These are the other units we can express our hardness. Majorly we are going to use a ppm, that is parts per million. And this is the relationship between these units above we have mentioned. That is 1 ppm is equal to the 1 mg per liter, that is equal to the 0.07 degree Clerk, and that is equal to the 0.1 degree French. And these are the relationship between various units of hardness. Now we have the other next important topic in our module, that is determination of hardness by complexometric method, that is EDTA method. We are going to estimate or determine the hardness of water by using a EDTA method or a complexometric method. It is one of the most important topic in our water and its treatment, and also as well as in the experimental wise in the chemistry lab, it is a very important. So what do you mean by EDTA? EDTA is nothing but ethylene diamine tetraestic acid. So we have two amines, ethylene and tetraestic acid, 4 tetraestic acids. This is the structure of EDTA. Now this is a complexometric method because the EDTA is used as a complexing agent. Why we are calling it as a complexometric method? Because the EDTA solution or the EDTA salt which we are using will be acting as complexing agent. Now, EDTA forms complexes with the different metal ions at pH of 9 to 10. So, to maintain this pH, we are going to add a buffer solution, that is ammonical buffer, which will maintain a solution to pH 10. This is your ammonical buffer. So, you are going to add this buffer solution in your experiment so that it can maintain the pH level of 10. Why we have to maintain a pH of 10? Because the EDTA forms complexes with the metal ions at pH of 9 to 10. And an alcoholic solution of indicated, that is erythrome black tea, we are using as a the disodium salt of EDTA is used as complexation since solubility of EDTA is very low. Now we are going to use a disodium of EDTA. What we are using here, one is a buffer solution which maintains a pH of 9 to 10 and also indicated, that is erythrome black tea, and EDTA as a complexing agent. Now, simply principle it involves is metal ions. Metal ions are nothing but sample of your water, and when it is mixed with the EBT means erythrome black tea. When it is mixed with the metal ions, that is water sample, in presence of the ammonical buffer, that to maintain a pH of 10, it gives you a metal ions EBT complex, that is of wine red color. So, this color you can see in this solution. You are taking a flask and you are going to add a water, and to this water you are going to add indicator, that is EBT, and to this you are going to add ammonical buffer. Now, this color of this solution will be changing into wine red color. Next, what we are doing is titration. That means you are going to take this solution and going to titrate with the EDTA. Now, it forms a color, like when you mix this metal ions, EBT complex, that is wine red color, to the EDTA, that is colorless, you are going to get separation of the EBT as a blue color, since it is forming a complex, a stable complex. We'll see detailedly how the procedure involves. So, coming to the procedure of EDTA, that is estimation of hardness by EDTA method or complexometric method, involves into the first step, that is preparation of standard solution of MgSO4, magnesium sulfide. Okay. So, now first step, we are going to prepare a MgSO4 solution. That means we are going to do standardization of MgSO4 solution. To this, for the preparing this standard solution, first we need to take magnesium sulfite MgSO4 salt, that is 0.25 grams. You are going to weigh 0.25 grams of MgSO4 solution and you are going to transfer it into a standard flask. This is your standard flask. You are going to add 0.25 grams of MgSO4. You are going to add 0.25 grams of MgSO4. This is your salt in a standard flask. So, if you observe a standard flask, you can see a mark here. So, you have to fill the mark with the distilled water. You have to dissolve this solution in the distilled water like this, so that you can see a formation of clear solution. See, weigh approximately of 0.25 grams of MgSO4, transfer into a 100 ml standard flask. That means you have transferred the salt in a standard flask, that is 100 ml. Now, you are going to fix the funnel and dissolve the minimum quantity of distilled water. That means till the mark you are going to fill the distilled water, and so that you can see you have to dissolve the salt so that you can see a clear solution. Now, make up the solution up to the mark with the distilled water and shake the flask well for the uniform concentration. Why need to get a uniform concentration? Because the salt we have added should be completely dissolved. Then calculate the molarity of MgS44. How we are going to calculate is weight of the salt we have taken divided by the molecular weight of the salt. Weight of salt. How much we have taken? 0.25 grams divided by the molecular weight of the salt, that is 246, and into 1000 by 100. So when you calculate this, you get a molarity of MgSO4, that is 0.01 m. M means molarity. In the first step, you have prepared the standardization solution of MgSO4. Coming to the next step is the standardization of EDTA solution. Now in second step, what we are doing is we are going to start the titration process by using of the MgSO4 solution that is prepared in the step 1. So from the step 1 we have prepared this is MgSO4. Here you can see this is from the step 1, that is MgSO4 solution. This we have gotten from the step 1. So whatever the solution we have prepared in the step 1, now this solution we are going to pipette out 20 ml into conical flask. In the conical flask you are going to pipette out. Now to this 20 ml of MgSO4 solution, we are going to add the indicator. What is the indicator? Here we are using, that is EBT indicator, erythrochrome black tea, and also the buffer solution. Why we need to add a buffer solution? To maintain pH of 10. Now all these mixed in a conical flask, and this conical flask solution is titrated against the EDTA solution that is taken in burette. Now when you are doing titration, you can see slowly formation of blue color. First it forms a wine red color before titration. So before titration you can see wine red color. So when you are doing titration with the EDTA solution, you can see formation of blue color. That means that is your end point. So pipette out 20 ml of MgSO4 solution into clean conical flask. Add 2 ml of buffer solution and 2 to 3 drops of EBT indicator. So it gets into wine red color. Take EDTA solution in a burette. After titration with the EDTA solution, it will turn the wine red color into the blue color. Now you can stop doing the titration and note the titer values. This is your step 2. Now from here you are going to calculate the M2, that is molarity of EDTA you are going to calculate. Coming to the third step, here we are going to find out the total hardness. Total hardness means what? It is having the both temporary hardness and permanent hardness. So how we are going to calculate the total hardness? So to calculate the total hardness, first we need to take a tap water. From tap water we need to take 20 ml of tap water into the conical flask. Same, again we have to add the indicator, EBT, and buffer solution. Buffer for the pH 10. Now when you titrate with the EDTA, again you can see the formation of this wine red color turns to a blue color, that is your end point. So pipette out the 20 ml of tap water into 250 ml of conical flask. Now you have to add 2 ml of buffer solution, and to this you have to add the EBT indicator. Now when you are titrating this wine red color solution with the EDTA, you can see a formation of blue color in the conical flask, that is your end point. Now stop doing your titration and note down the titer value. Now you have to repeat it for the 3 times to get the concrete values. Now from this step you are going to calculate the total hardness. Fourth step is the standardization of permanent hardness of water. That means we have calculated total hardness from tap water. Now the tap water is having both temporary hardness and permanent hardness. But what we are doing in fourth step, we need only permanent hardness. So to remove the temporary hardness, we are going to boil the water. So we are going to take a tap water in a beaker and we are going to keep it for some time for boiling. So in the process of boiling, temporary hardness is removed, so that only permanent hardness remains. Now you have to take that boiled water and cool the solution, filter the water into beaker. Now from that beaker, you have to pipette out 20 ml of water. So the boiled water, you are going to cool it. Now pipette out 20 ml of hard water plus EBT indicator and also the buffer solution. Now this solution you are going to titrate with the EDTA again, and now you can see formation of blue color. The wine red color turns to a blue color. In fourth step, you are going to calculate the permanent hardness of water. So hard water in presence of EBT and the buffer solution, a wine red color solution is obtained. This wine red color solution, when you are titrating with the EDTA solution, you can see formation of blue color. So blue color means here it is the end point. You have to stop doing your titration and note down the concurrent values. We'll say practically, one is the indicator we are taking, buffer solution, EDTA solution, beaker, dropper, conical flask, burette stand, funnel, magnetic stirrer. Okay. So we are taking a beaker of water and that is added with the Erichrome black tea indicator, and we are going to add the buffer solution. Now it is turned to a wine red color. This wine red color solution is now titrated with the EDTA. So before titrating, you have to take a burette, fill it with the EDTA solution, keep the flask on it, start doing the titration. You can slowly observe that while adding of EDTA into our conical flask, this wine red color turns to a blue color solution. These are the references.